Okay, this video will continue chapter 9, worksheet 1. So we stopped at this part here whereby I asked you to go back and finish it up. So you go and finish up by yourself first. Once done, check your answer with what I have on the screen right now. Okay, make sure that there could be different ways to solve, but these are the ways which I obtain my linear equation. So you just cross-check with what you have. The answer may be different depending on how you rearrange your equation, etc. But more importantly is that when I rearrange any equation to the linear form, y equals to mx plus c, your x and y axis here should not have any constants like a, b, p, q. They should all be contained within your gradient m and your c. Okay, axis should not have any constants. You should only have x or y. Even your y axis here can just be simply in terms of y, etc. Okay, so just check. So these are, you can just pause the video to double check. This is for this part of the worksheet, and this is for question 6, 7, and 8. Okay, I will move on to example 3 directly. So if you need more time, you can just pause this video. Let's look at example 3 now. Okay, example 3 here, I'm given this equation here. The question says, what are the axes we can draw to obtain a straight line graph? So from here, y equals to 5x times root x minus 6x. If you recall what is the general equation of a straight line graph, I need to change my equation to the form of capital Y equals to mx plus c. The variables should all be contained within the x and y here. So let's rearrange here. There are actually two different ways which you can go about doing this. My first very simple way is simply I can divide the whole thing by x. So method 1, if I divide by the whole thing by x, I'll get y over x equals to 5 root x minus 6. Okay, what I'm doing over here is that divide by x. Divide the whole equation by x. What some of you may also do instead of dividing by x, you may want to divide the whole thing by x root x. So you may get y over x root x, then this will become equals to 5 minus 6 over root x. Okay, so there are different ways to solve. Over here, let's say if I use method 1. Okay, method 1 here, the axis here. Okay, from method 1 here, x-axis and y-axis are simply x-axis is root x, y-axis is y over x. Okay, and then from here we can also obtain the gradient. Gradient is the m. Gradient in this case is equals to 5. Y-intercept in this case will be simply equals to negative 6. Okay, so over here I've answered part A and part B. A and B and B. Okay, this is for form 1. But let's say if I choose to do form number 2, then you will have different x and y axis. Over here, form number 2, your x-axis will be simply 1 over root x. Your y-axis will be y over x root x. Gradient m equals to negative 6, and your c or y-intercept will be 5. Okay, so different ways to do it. It's always best to think about what is the easiest way which will allow you to make less careless mistakes. So if you observe between method 1 and method 2, try to think for about a short while, which form is easier to use when I want to convert from this equation form here to a linear form. Which form do you think is easier to use? Okay, so actually there is no right answer. To me, I would think that method 1 here will be easier because the calculations seem much easier. I only have divide by x and here root x over here. Whereas for method 2, I have x times root x. If you are careless, you may make careless mistakes in your calculation. But either way, it's fine as long as you can get the correct answer. So let's look at method 1, part C. State the range of values for x, which the linear form is valid. So if you recall, if I have a square root over here, this x must be at least 0. And if I have y over x, x cannot be equal to 0 because denominator and the fraction cannot be 0. So therefore, the conclusion is that the range over here is that, therefore, x must be greater than 0. The reason is because negative values of x are not valid for root x, and in this case over here n, x cannot zero, x equals to 0 is not valid for y over x. Okay, and therefore this is how we obtain the range x is greater than 0. And for part D, simply to sketch this straight line graph, since I know what is the gradient and the y-intercept, this is very simple. So to sketch this, simply I draw my axis in this way. My axis can be drawn as such. I know that my y-intercept is -6, and this is a positive gradient, which means that it is a positive straight line graph going upwards. My graph is simply a graph that looks something like this. Okay, this y-intercept here is simply -6. Okay, and I label the axis. My y-axis is y over x, whereas the x-axis is root x. And then I label the equation of this graph. So maybe I'll change this line to make it clearer. So I label the equation of this graph. This graph is y over x equals to 5 root x minus 6. Okay, so how do I find the x-intercept? Because in a sketch, usually you will label both your x and y-intercept. So to find your x-intercept, okay, to find x-intercept, in this case here, please note that it is not let y equals to 0, but let y over x be equals to 0. Okay, therefore, 0 equals to 5 root x minus 6. Root x is equal to 6 divided by 5. This is your y-intercept, your x-intercept now, not x but root x. So therefore this value here is simply negative, not negative, sorry, but 6 over 5. Okay. So remember, the reason why it is not x but root x is because now when I convert this to a straight line graph, your x-axis becomes root x, not x. Okay, so this is how we find the x-intercept in this case. Okay, part 2, if you want to use this, can, as long as you check that your intercepts and how you find this are the same, meaning that how you label your x and y intercept, your y-axis and x-axis are also labeled correctly. Okay, so this is for example 3. Let's look at example 4 now. Example 4, I am given this graph. This is a straight line graph. My y-axis is given to be this. This is my x-axis. And I'm given 2 points over here. Range of x is more than 0. And the points pass through these 2 points over here. Express y in terms of x. So for this question here, very simply, for part A, okay, for part A over here, I can express this as such. So based on this graph, I know that for any straight line graph, I always have this standard equation, y equals to mx plus c. Okay, so from here, we can first find out what's the gradient first. I know 2 points on this graph, which are 4, 6 and 1, -3. So if I sub in these points, okay, next step is find gradient m from these 2 points, which are 1, -3 and 4, -6. Okay, so the gradient here, m, is simply y2 minus y1, 6 minus -3 over 4 minus 1. You'll get simply 9 divided by 3, which is 3. Okay, so therefore I found that m is equal to 3. So therefore this graph here is y equals to 3x plus c. How to find this c here? Simply just sub in any point. So let's say I sub in I choose maybe 4, 6. 4, 6 into equation of line. Therefore, I have 6 equals to 3 times 4 plus c. C is simply equals to -6. So therefore, y is equal to 3x plus, not plus, but -6. Okay, but note that in this graph actually, this capital Y and capital X is actually this form. Capital Y is this y-axis here, and this is your x-axis. So if I replace this, this will become y plus 1 over x equals to 3 root x minus 6. So therefore from here, if I cross multiply to get rid of the fraction, y plus 1 is simply equals to 3x root x minus 6x. Therefore, y equals to 3x root x minus 6x minus 1. And this is for part 1. I've expressed y in terms of x. Okay. Then the next part, part B, find the value of y when x is equal to 6. So in this case over here, note that this is y, so therefore I just need to sub for part B. Sub x equals to 16 into equation of line. Therefore, y is simply equals to 3 times 16 times square root 16 minus away 6 times 16 minus 1. Okay, evaluate this out into a calculator, you should get y equals to 95. Okay, then for part C, okay, given that this line passes through the point k, 4. So this one here, k, 4, very important. When I sub this, to find this k here, I will have to sub this back into the equation. But this line here passes through this point, it is based on the graph drawn on this equation here. Not this one, but this equation. Okay, so when I sub my x and y, my capital Y is 4. So let me label. This is capital Y, this is capital X. And this capital Y and capital X is represented by these two forms. So do not sub this back into this equation here, the small y and small x. Different labeling. So over here, sub this point k, 4 into equation of line. Okay, and I use the equation of line from this part here. Okay, so using this point here, my y value is 4 equals to 3 times k minus 6. Therefore, k is simply equals to 10 over 3. Okay, this is for part C. Okay, and the last part for part D, given that 3, 3 lies on this line here, find the corresponding values of x and y. So therefore, this is telling you that for point 3, 3, it means that my x value here is root x is equal to 3 and y plus 1 over x is equal to 3 as well. So from there, to find the corresponding values of x, therefore, x is equal to 9. And from here, I can sub this value in. Okay, so sub x equals to 9. Y plus 1 over 9 is equal to 3. Y plus 1 equals to 27. Y equals to 26. Okay, and we have solved this question. For given this point that lies on this line here, the corresponding values of x and y. So very important thing to recall is that any point that lies on this graph, the x coordinate is not x but root x, and y plus 1 over x. Okay, this is when I convert this and I base it on my new x and y axis labeling. Okay, so now moving on to the last example of this worksheet, example 5. Okay, this is a O-level question from 2011. Okay, this diagram here shows part of a straight line drawn to represent the equation, this equation here. So I'm turning this equation here was turned into a straight line graph. This is the axis given. Okay, so given that the line passes through this point here and has a gradient of -3, find the values of a and b. So I know that for any straight line graph, we always start, any straight line graph has this equation, y equals to mx plus c. Okay, and we are given that gradient here, given that gradient of line m is equal to -3. So therefore I know that capital Y is equal to -3x plus c. From this graph here, I know that the point 2, 6 lies on this graph. So therefore, sub this point 2, 6 into equation of line. This will help us find the c, which is an unknown. So therefore, 6 is equal to -3 times 2 plus c. Therefore, c will be simply equal to 12. So therefore, for this graph here, therefore, y is equal to negative 3x plus 12. And now that I've obtained this, I can now find the values of a and b respectively. I start by this given equation over here. Okay, so from this equation here, okay, I have, move this to one side. From this equation here, I have y equals to a over x plus b. So I need to convert this equation into this form here, whereby my y-axis is xy, my x-axis is y. So if I cross multiply, xy plus by equals to a. Then from here, I rearrange the equation. Xy equals to negative by plus a. So therefore, by comparison, if I compare this to my y equals to mx plus c, this y is your x-axis now. Negative b is your m, a is your c. So therefore, negative b, can we write this out? M is equal to negative b, a is equal to c. So therefore, based on this, by comparison here, from this original form that we obtained just now, my gradient m is negative 3, c is equal to 12. So therefore, this tells us that negative 3 is equal to negative b, therefore b equals to 3. Okay, and as well, a is equal to 12. And from here, we have solved this question very simply. Okay, so this is the last example for this question. Once you're done, please go back and finish up the assignment questions for this worksheet, assignment questions which are over here. Okay, so that's all for this video.